Alrighty, good morning everybody and welcome to the WolfSSL live webinar on doing WebSockets with cURL with cURL founder and maintainer Daniel Stenberg. My name is Kajal Subkoda and I will be moderating this webinar. As a reminder, all attendees will be in listen-only mode. If you have any questions, please feel free to use the Q&A box or raise your hand to be unmuted if you'd like to ask the question live. This webinar will also be recorded and made available on our YouTube channel shortly after the presentation. And I invite everyone to follow us on Twitter at WolfSSL, as well as follow Daniel on Twitter at Badger, as well as all of our other socials. And please feel free to email us at facts, that's FACTS @wolfssl.com if you have any additional questions. And now I'm gonna leave it to Daniel for the technical presentation.
Thank you, and welcome everyone. So I'm going to try to talk to you a little bit about WebSockets with cURL, or is it WebSocket? So anyway, just a reminder, I'm Daniel. As said, I am Bagder at Twitter and Mastodon and everywhere. I am here for WolfSSL. I do cURL. That's my website with everything else. So this is sort of what I plan to do today. First, just a few fundamental things about WebSocket, the protocol, and a little bit how it works, what's the difference compared to other protocols, how you enable it in cURL, a brief overview of the new API calls to manage WebSockets, and the two different, you can use these ones in two different ways, two different API models in libcurl. I will go through them and show with code 2 examples how you can go about and write your application to use libcurl and do WebSockets, and some words about the possible potential future for WebSockets, the API and everything in cURL. So hopefully this is not going to be too long. I expect to be done within 15-20 minutes. And of course, if there's anything you sort of come to think about or want to ask, so hit that Q&A thing in the Zoom client and enter the question, and we'll get to those in the end, I promise. So WebSockets, as in singular, right? That's the name of the protocol, is actually WebSocket, even though we always call it WebSockets, or a lot of people do, I do. So we sort of mix and match between WebSocket and WebSockets. It's still the same thing. It's this protocol that was made in RFC back in 2011, so it's quite old by now, 6455. It defines a sort of TCP-like communication over HTTP. I think the primary purpose was to basically made JavaScript and web applications possible to talk to the server and have more or less real-time communication back and forth in a little bit of a TCP-like manner. Although this is WebSocket is actually message-based. It's not a stream like TCP. I'm not sure that matters, but still, that's how the protocol is designed and defined. And you set it up with these WS:/ or WS:/ URLs. The first one then being without TLS, and the second one, the one with 2 S's, using TLS. I guess the second S is for secure. So WS for WebSocket, of course. And of course, a key thing here is that so far the supporting curl and libcurl really is only done over HTTP 1. You can actually do WebSocket over HTTP 2 as well with a little extra thing. I mean, there's a protocol defined and there's an RFC for how to do it. Curl itself does not do that at this point in time. I'll get back to that little detail. So WebSocket as a protocol is different, and I mean different in the way that it is different than other protocols that it is supported by curl and libcurl, but it has been a protocol and a feature that has been requested for a very long time. in our annual user survey, we try to, we have this recurring question, what things would you like to see supported in curl in the future? And this question has always been sort of, the answer WebSocket has always been frequently selected by respondents for a number of years. So eventually we found a sponsor and we got some effort and time and energy and implemented it. So it is not actually a really good fit for libcurl because it's not a strict upload download protocol. So it's not just, initiate a download, stream the entire thing, or initiate an upload, stream the entire thing. This is more, again, TCP-like. So it's for sessions. So you can send and receive whatever in whatever manner, depending on what kind of setup and for particular things. So therefore, it's not a perfect fit for libcurl, but it turns out that a lot of users are already doing WebSockets on top of libcurl, and they use libcurl to sort of set up the WebSocket and then glue some other WebSocket library into the mix and work like that. And by us supporting this in libcurl itself, it simplifies a lot, and it is web transfer stuff. So it's not the perfect match, but I think it fits. So the WebSocket support in libcurl, we introduced it back in October last year. So it's been in the code for a while now. So it has had a little time to mature, but it has also been improved step by step, of course, release by release. So I really encourage you. So if you want to try this, go with an as recent version as possible, because we have fixed bugs along the way. And we still mark this feature as experimental, meaning that if you get a libcurl from somewhere else, like in your Linux distro or however you get it, it's likely that you won't have WebSocket support enabled, because experimental means that we discourage people from using this in production, and we reserve the right to modify the API and behavior going forward before we remove, or rather until that day when we remove this tag. So we use this as a sort of an experimental mode. It allows us to move forward a little bit faster, try out things, and get your feedback how things work. So by all means, try it out and tell us how it works, and point out bugs and tell us what's missing for this to work for your use cases. Because as always, when we implement something new and provide a new API, we need people with actual real use cases to try it out and use it and tell us what doesn't work and what works and so on. So, and really, it's very good also to get that feedback, what actually works, and sort of, yes, everything works, thumbs up. That's also good feedback, because at some point we want to remove this experimental tag, right, to make sure that we can call it production ready, and carve the API in stone and ship it forever. So we need to get feedback enough to know when to remove this experimental label. So this means that you need to explicitly enable WebSockets in the build to have it there. If you build with configure, which sure, not everyone does, but if you do it with configure, you just use this option -- enable WebSockets with configure, and then you get a build with WebSockets enabled, and then you just build everything like normal. And actually, even if you don't use this option, the API will exist, so the symbols will be there if you build libcurl without this option. But the functions, they don't do anything if you haven't built with this option. Basically, they're just dummy functions to make sure that they exist in the API. So when you use WebSocket, or when anyone uses WebSocket, it's actually a regular HTTPS transfer that is quote unquote upgraded to WebSockets, and it's actually not only quote unquote upgraded, it is a regular HTTP or HTTPS request that has this header that asks it to get upgraded to a WebSocket. And you signal this request, I want this HTTP request to upgrade to WebSocket. You signal that by using these dedicated URL schemes, WS or WSS, // hostname, blah, blah, as usual. So basically, this is just like your ordinary HTTP or HTTPS URL, but you replace the scheme with these schemes. And that will tell libcurl that it needs to do a regular HTTP request and upgrade that into a WebSocket. And that means that it will send an HTTP request, an actual HTTP request GET, and with this upgrade WebSocket header field. So that means that if the server doesn't want you to upgrade to WebSocket, it'll not respond with the 200 and respond properly, and it will respond something else, and this will make your WebSocket transfer fail if the server denies you. Otherwise, the server will respond with a 101 switching response code, and in that switch, that basically the server saying, okay, I hear you, we have now switched the connection to a WebSocket connection, and from this moment on, we speak WebSocket. So it's fairly easy from a client point of view and from a libcurl user point of view actually as well. And to support this, now we have switched into a WebSocket mode. We also in libcurl added 3 new APIs to help you communicate and talk, speak, send WebSocket data. And those are really easy, fairly low level. So you need to be able to receive WebSocket data. So you have this curl. Sorry, I have some pop-ups on my screen here. So you have this curl WS receive, which then of course receives WebSocket data. You have the corresponding curl WS send to send WebSocket data, and we have this third one that is called curl WS meta or meta. It returns meta information about incoming data. I'll explain in a moment when you need it. So we have these 3 new function calls, and those are only used for your WebSocket communication, and hence the name, right? So they're dedicated for just WebSocket support. And when it comes to WebSocket, as I mentioned, it is a sort of TCP-like, or it's meant to, in the sense that you can send whatever in either direction, and it's just data sent, and you can actually in WebSocket you just say if it's text or if it's binary, and if it's text, it's always UTF-8. But anyway, you send as you say, I've tried to illustrate it, this little arrow, right? So first you send one message, and then you send another message. That's basically what you send in WebSocket, message-based. A message, another message, another message, and it can contain anything because the protocol just sends data. So it depends on what you and the client and the server agrees on, right? Or agree on. But a message can consist of a number of different frames. So a message is split up with a number of frames. It could be 1 frame, could be 3 frames, or any number of frames, really. I'm just trying to illustrate it here so that you understand that the message is split in multiple frames, right? That's exactly what the WebSocket RFC says, the 6455. It defines WebSocket like this. So basically, you send a frame and you send another frame, say there's going to be more data to this message, and more data and more data and more data. So you chain all the frames until the last frame, then you know the message is complete, and that's the message. But to complicate things, you will probably understand what I'm talking about in a second, because that's how WebSocket works. But in curl, we complicate things a little bit more because that's how we are, right? So we deliver these frames in potential fragments. So sure, that's 1 frame. It might be delivered in 2 fragments, and the other frame might be delivered in more fragments, or just 1 fragment. And the message that is just 1 frame could also be delivered in multiple fragments. And why do we complicate it this way? But first, of course, I just want to emphasize that this is how we split it up in libcurl. So you might not get full frames. You will possibly get a partial frame per data delivery occasion or moment or whatever. When you get data, it is a fragment, and that fragment might not be an entire frame, could be an entire frame, could be a smaller part of a frame. But they're always aligned, so they're always on frame borders like this. I'm trying to illustrate here with the blue little arrows here. So you know that you will only get you get frames that contains that's a part of the same. The fragments are part of the same frame, and when the frame is complete, you get a new fragment for the next frame and so on. So you get a number of fragments for each frame, and in the end, you have gotten the complete message. And the reason why we complicate it like this is, of course, because those things here, these beauties, the yellowish boxes up here, they can be immensely big. According to the protocol, there can be up to a power of 63 bytes big, which, you know, that's sort of impossibly huge. But the point is that they can be so big that it's not possible for the libcurl API to promise and deliver the entire ones. So it will deliver partial ones because it cannot always deliver the big ones. And really, the protocol is so flexible, so it's possible that you will find a place that, you know, delivers one frame that never ends, basically, or it can deliver millions of tiny frames. It's all up to the implementation, sort of the client server side, what they have agreed to do. And of course, then in the libcurl API, these fragments, they are smaller, and they are sort of determined, that their sizes are determined by things like buffer sizes and what you ask for and what you set up libcurl to do. So they are always going to be in X number of kilobytes maximum size. So if you're talking to a WebSocket server that is sending very, very big frames, you will get them as a lot of number of fragments that are only a number of kilobytes each. So just keep that in mind. And also to complicate it a little bit more, if it's not complicated enough, in libcurl, we also decided to implement WebSocket support with a raw mode. Basically, this is, I'm not going to get into this a lot more, but I think it's good to know for anyone who is interested in WebSockets with libcurl, because this is basically a way, if you already have a WebSocket implementation, or if you want to, you know, bolt on another WebSocket library or something, you can ask libcurl to just set up WebSockets, deliver everything raw, and accept data outgoing completely raw. That means do not try to interpret the bits and bytes and everything, just deliver it to the application. Basically, this is a way to better work with existing applications that have already done with WebSockets and already have their own WebSocket implementations, but now they can sort of integrate better. Mostly, this is not for new applications. You rather avoid the raw mode, because the raw mode sort of just passes everything through. It assumes that the receiver of this data, your application, really knows WebSockets, and then you pretty much already have to have a WebSocket library or whatever. So I'm not going to touch this mode a lot more, but I'll mention it. If you're that kind of application, if you have the kind of application, you know that it exists and you can sort of explore that. Otherwise, when setting up a WebSocket transfer, there are two different models. And really, there are two different models, primarily because there are some pros and cons with both, and I'll try to explain them a little bit. First, we have the write callback style. If you used any libcurl programming before, if you've done any libcurl programming transfer, any other protocol, you know that the way to receive data in an application, you set up a write callback, because it's from the point of the library, right? So the library needs data that the library receives, it needs to write somewhere. So you provide the write callback when the library needs to write the data, right? So it will deliver downloaded data to the write callback. So it wants to write them somewhere. And we can set up a write callback to receive WebSocket data as well. It's very similar to regular libcurl downloads. You just get this write callback called over and over when you get WebSocket data from the remote. Quite simple and understandable, because you set up the connection. If there's data coming from the server that is WebSocket data, it'll get sent to the right callback. And this is really smooth if you have a download-oriented WebSocket stream. And a lot of WebSocket streams are like this, basically just sending data to you as a client, usually in the way people have set it up. So possibly as a JavaScript thing on a web page, for example, just get data from the server whenever the server has data to send. And then it becomes a very smooth way to just get the data when it comes. It scales really nicely from and that's a very easy way to do it if you have a lot of parallel WebSocket transfer, for example. And it's also, and of course, even though it calls your callback when you receive data, you can also just within that callback also send data back to the server. So it's perfectly fine to send data in the other direction as well. But since it's the right callback, it's very download oriented kind of setup. The other way to do WebSocket is when you don't have that download oriented thing. You have a more perhaps interactive session, or you want to do a lot of things. Maybe you do things in the other direction. You want to upload stuff a lot or whatever. And then you go the connect only style, which sets up the connection and then pretty much hand over the connection to you to do whatever you want. Full receive send flexibility. You call the functions send receive whenever you want to do, and just send data, receive data, and check what you get, send whatever you want. It's when you don't have that download oriented use case, and it makes it harder to do a lot of parallel transfer. It's more, then you probably go with a single use per thread setup or something, possibly. Anyway, I will show you with some code exactly how it works. So basically, if you have this callback style, you set up a transfer pretty much like you do with any other transfer with other protocol. You could, if you've done any kind of libcurl coding before, you can recognize this setup. First, you create a handle with is in it. You set the URL, number 2 there. In this case, we use the WSS : which I guess is the most typical one, using TLS, secure the transfer. And we set up the right callback, call this function when we have data, pass in this parameter as to the user pointer, which, as you can see here, it passes on the easy handle itself to the callback. And I will show you in a second why that is convenient to do. So that the curl up the right data argument option, it sets the pointer that gets passed to the callback, right? And then you initiate the transfer, or you actually, you don't only initiate, you run the transfer. So this will run the entire transfer until it's done. And when it's done, you call cleanup, and that's the entire transfer. And what happened then in that right callback in number 3, the right callback is the usual stuff, how you manage receiving data, right, in an application. In this case, I made a very basic callback just to prove how it works. So pretty much, and I wanted to show you then the introduction of this curl ws meta function. It is a function that you can use within the callback to it returns, or it provides information to you about the data that you just got in this callback. Because as I told you, the callback will be called over and over with data when it receives data from the server. And with this function, you get information. What is this data that I'm receiving? So it returns a pointer to a curl ws frame struct, and it contains stuff like flags, what kind of data it is, is this the final frame or not, and it says if it's a binary or a text frame, and it contains an offset for this fragment within the frame. So in case you get many fragments for a single frame, you know how big the total expected size of the frame and how much is left of the frame after this fragment and stuff like that, so that you know you get information about the particular data that you're using. Right, so in number 7 here, you can see that it checks the flags to see if it's a binary packet, binary payload or a text payload. And then in number 8 there, you can see that it returns the correct value, which is the regular way you return values from a libcurl callback to tell libcurl everything is fine. I handle all the bytes. I return number of items, which is sort of, if you don't return number of items, libcurl will think something went wrong and it will return an error for the transfer because obviously your callback failed somehow, so it couldn't continue. So of course, if you do find an error within your callback, return something else and items, and you will get an error return from that transfer. So as you can see, this is very sort of libcurl-ish style how to do this code. Just set it up, get a transfer, handle the data, put it somewhere, write it somewhere, and it'll just continue until the transfer is done, and then you're done, and everything is fine. But you, in a more complicated way, when it's not that download centric, right? If you set up a connection and you want to have some ping pong back and forth, sending data, receiving, checking, which possibly is the way you actually want to use WebSocket. Well, in a lot of cases you do. So then you have this connect only style, which is then not using the right callback. So in this example, and both these examples, by the way, are nowadays they exist on the curl website. I'll show you some URLs in a second. So then you do it like this. This is the other way to use the WebSocket API, right? So you set up, you create the easy handle. I want to do a transfer, and I want to do it to this WebSocket resource, wss:// for example, possibly another host name in your case. And then, wham, the new stuff here. You set the connect only to 2. Okay, it's not the very most sort of readable thing to set it to the number 2. We should maybe consider doing a fancy fine name for this and provide a defined name. But anyway, this is how it works now. You set this curl opt connect only to 2, which it basically means connect, or it means set up WebSockets to this server and nothing more. So when you run the curl easy perform here in number 4, it will only set up everything and enable WebSockets. It won't actually do any WebSocket. It will just take the transfer long enough so that WebSocket has been enabled. And if it works, it returns fine, right? It returns okay. If it fails, you have to fail and you do something else. But if it works, and in this case, you see here in number 5, I decided that so it worked to set up the transfer. We have now gone to the point that we can speak WebSocket to this server. So we call the local function I decided to call WebSocket. Very creatively named. But anyway, so this is my very, very simple function WebSocket. And in my case here, you can see that it calls a function. This is mostly just a dummy function to show you how a particular WebSocket application could work, right? So in this case, it just calls the function, as you can see, called receive any at the top. It sends a ping and it tries to receive a pong, and then it sleeps for 2 seconds and then does it all again. And then when it has done that 10 laps, it calls the function WebSocket close and it returns, right? So if for number 7 there, you can see that sure, if one of those functions fails, it will also return, because then it failed then it means something went wrong WebSocket wise, right? And in this function, in this case, I show you with a ping and a receive pong. Let me see. I think I have a function called WebSocket close. So basically, to show you how the receive any function works, basically means check if there's data incoming from the server, and it calls the function curl ws receive with a buffer. Send me everything you have if there's data incoming, and then you get that. If there's no data, it'll just, in this case, this is just a dummy function. It doesn't actually do anything with the data. I'm just sort of here showing you how it could work and how it could receive data. In this curl WS receive function basically asks, receive everything that you have got from the server, all the WebSocket data. And if you can check this 1, 2, 3, 4, 5th argument called meta here in the function call, it will get a function, or it will get a struct pointer to a struct to that same curl WS frame struct I talked about in the callback case, which provides information, offset, type, and more about the WebSocket data that you just received with this function. If you receive the data, so you get a meta pointer, meta struct pointer, explaining the data, whatever you received there in the buffer. But you're right. So I'm reading the question here. But so the flags thing there, I showed you before. So you actually get multiple flags in that flags option, right? So it might actually you get more. It says binary. It could be a close. It could be a continuing. So there are a few different flags that you might get set per. Well, actually per fragment, but the fragment is part of a frame, a WebSocket frame. So yes, you would probably test for more flags than just the binary one when you check that flag argument or a flag struct field. So yeah, that was number 9, checking and just to show you how I imagine this case of the ping function. So there's this concept in WebSocket called ping. It's not an unusual concept, right? It exists in a lot of protocols. So since WebSocket is meant for long-lasting connections, so that keep them up for a long time, you need something to exercise the connection so that they don't just go completely idle, because idle connections will get disconnected by firewalls and whatever is in between you and the server. So therefore you need to send a ping every now and then to show the world that the connection is still actually active and working. And when you send a ping in WebSocket, the other end is supposed to send back a PONG with the exact same contents in the data. So in this example here, in the bottom there, this shows how to send a ping then with curl WS send. Basically, you decide what kind of payload do I want to include in the ping, and then you tell it, here's a ping, I'm sending a ping, and then you send it. Right, and you could then do the sort of the receive PONG in a similar way. You would, yeah. I don't have that as in my slide here. You can actually check that out because, again, I have that as an example on the website. And if you download the source code today, you will get that example included. So as I mentioned, right, I already told you. So ping, libcurl will automatically respond to server pings. So the server pings will always be sort of excluded. You won't see them because curl will itself handle them and respond with a PONG as soon as it can. But it will not send any pings by itself. So you will be responsible for sending pings yourself, and then the server is supposed to respond with a PONG. That might be something to consider, how to sort of enhance going forward. But this is how it works right now. And again, it's experimental, right? So there's stuff we might want to enhance further. So I tried to document all of this. So if you go to the website on these URLs, you can find documentation for everything I've told you so far. So you go to the libcurl-ws webpage, which is top one. I actually did this. I wrote this web page, this man page, just a few days ago. So it's brand new. But anyway, that's sort of the overview of the API and how to use the APIs. And then you have the different independent man pages, documentation pages for each of the new API calls, WS receive, WS send, WS meta. And then the two examples I showed you some snippets from, they're called WebSocket and WebSockets CB for callback. So they exist there, and you can build them and you can try them out and sort of experiment with them, because I want to show how to do some sort of basic setup WebSockets, and they might be fun embryos or skeletons to start with, and take it away and see what you can do for real with those examples. Right, and by all means, if there's anything that is wrong or unclear or weird in the documentation, or if whatever I've said today, we should really, I would love to get your feedback and bug reports on the documentation as well, to make sure that we can really polish those things as well to make them really good. Because as I mentioned already, we need feedback to be able to have the guts to remove the experimental tag at some point. And until we do that, we haven't done it yet, right? Until then, we reserve the right, and we hope to sort of take that opportunity, this advantage that we have now, as it is experimental. We can actually fix the APIs and change things if we find things that are bad, awkward, uncomfortable. It doesn't really suit for this in a good case. Then just bring it up, and we can work on fixing that to make sure that it actually becomes a really good API before we have to carve it in stone and support it forever. So we can then also, for example, discuss, are there any missing API calls in this set of APIs, so the family here that we provide for WebSockets? There's, for example, no way here to wait for activity on a WebSocket connection, WebSocket transfer. Maybe we need a curl WS poll to ask curl to wait for incoming traffic for this amount of time. Maybe I decided to hold off because I need feedback here. I didn't want it to go sort of just guess too much. So far, we haven't had the need for it, but I'm also very keen on learning from people with actual use cases to hear how things work. I've already been told that someone wanted a callback when you do the right callbacks model of the API, someone wanted a way to send the data before that first data arrives. So maybe a callback to allow the application to send data before the right callback is called the first time. And then there's, of course, the ability, opportunity, maybe future distance, perhaps, to go support for HTTP2. Supporting HTTP2 is straightforward, I guess, because there's an RFC already explaining how to do it. We have HTTP2 support in general in curl, so it should be doable without sort of sacrificing too much. And then, of course, there's this new protocol called Web Transport that really is sort of WebSockets taken to the next level then for over Quick and HTTP3. So I'm not sure how much that has in common with WebSocket anymore, but it's at least a discussion that is easily sort of to go into. And of course, I sort of left out the entire thing about the command line tool and how to do WebSockets with that. Right now, it's very rudimentary. Right now, it's just download a sort of callback method. So if you use curl, the command line tool, and you specify a WebSocket URL, it will set up the connection and just wait for data to come. And it works if you get data like that, but there's that's kind of a limited way to approach it. And I'm open for suggestions and ideas how to improve that. And I expect that we will improve, and especially sending data the other direction, how to do that in a proper way. Right now, it doesn't do it at all, but it should probably do that. And we have some ideas, and we're of course interested in feedback and ideas there too, and how to do that in a really good way to make it working for people. So basically, that is WebSockets with curl, with libcurl really today, and that's what I wanted to tell you. So are there any more questions, perhaps? I answered one a little bit there about the flags. Could be more, I guess.
Yeah, please feel free to use the Q&A box or even raise your hand if you'd like to ask the question live at this moment. While we wait, as a reminder, everyone can also email us at that's FACTS at wolfssl.com if they have any additional questions. And again, this webinar is being recorded at this moment and will be available on our YouTube channel shortly after this presentation. If you'd like to receive a copy of the slide deck, please email us at facts, again, FACTS at wolfssl.com, and we'll be happy to send that over to you. Otherwise, if those are all of our questions, thank you, Daniel, so much for a fantastic presentation, and thank you everyone else for attending. I hope you all have a fantastic rest of your day.
Thank you, everyone. Goodbye.